let's talk about the Common Core standard. Let's put it down again. So it's geometry and it's congruence. That's what it stands for, okay? G for geometry and CO for congruence. And it is to be able to know, let's write this down, to know precise definitions of point, line, and plane. We're also going to talk a little bit about midpoint today, midpoint, and bisector. Okay, because we're going to combine the first two sections, because what I think you found already today was, that first section we read was pretty obvious, right? It was really obvious. We just had to put it in theorems, okay? So let's take a look at example 1. So example 1, draw a plane piece. So when we draw a plane, what I do to draw a plane is I like to draw kind of a little parallelogram thing. Okay. So it looks like a parallelogram. It's slanted. I don't really want it to look like a square. It's like a 3D. We're looking above it, three-dimensionally. Does that make sense? It's a perspective drawing. So it has to be plane P. So let's put P in here somewhere. Okay. And it contains line AB. So we're just going to draw a line and make it A, B. There it is. Easy. So I drew a plane. It's kind of slanted. Made it be lane P and drew AB in there. All right. Okay, let's look at 2. Am I doing all right? Okay. Okay, example 2. Draw plane N with intersecting line segment at point X. Okay, now this one's a little bit tricky, but go ahead and draw a plane. Okay, see if you can do this. Okay, hopefully everybody has pencil, because I want you to try and do this one without my help. Okay, just give it a try. This one's a little tricky because the line has to go down through it, so you can draw it. Okay, this is more like this. You can draw this. The line's coming down through it. Can you draw that? Through it. At line X. Can you draw that? So you can draw something that looks like that, okay? Give it a try. Think about it, all right? Definitely start here, right, with my plane N. If I want a line to go through, it says intersecting with line. So the plane is intersecting line. So a line's going to come hit it. Boom, right? Straight down, boom. And that's got to be X. And then this back part I'm not going to see for a little bit. So I do my little dash line. And then it pops out. Kind of like an arrow going through it. And that's... How many kids got that? Anybody get that? Nice. Nice. Okay, a little tricky, isn't it? Okay, example 3. I think example 3's got to be this one here. Example 3's got to be this one. See if we can draw it again, okay? Okay, draw plane N and M intersecting line AB. See if you can do that, okay? See if you can draw that picture. And if you have a tough time, don't worry about it. That's why we practice. We're just learning how to do it. I don't want you bored either. Oh,
No, I want this one.
All right. How am I doing? Am I going slowly enough for you? This one's kind of hard to draw. Think I've done this before, Isaac?
A couple times.
A couple of times maybe. Okay, it's coming together. How's that? Thumbs up if you got it. I want to see it. Thumbs up. Hey, that's quite a few thumbs up. That's pretty good. That's pretty hard to draw, isn't it? Okay, example 4. Here comes the easy one. The picture's there. Now, what's this thing about non-collinear? See this word non-collinear. What does non-collinear mean? Anybody know? Non-collinear? Non-collinear. Hey, a guess is okay. You can be wrong and not humbled. You can be wrong and not embarrassed. Anybody? Non-collinear? Non-collinear. I know, Mr. Davies, it's too early in the morning to think, right? Okay, well, here's what I think collinear means. Co means to cohabitate. Cohabitate means we're going to hang out together. So to cohabitate on a line, we'd all have to be on the same line. So collinear means basically, let's see, collinear means on the same line. Okay, collinear, on the same line. Does that make sense? Does to me. We're going to cohabitate, we're going to hang out on the same line. So 3 collinear points have to be on the same line. That's collinear. What if they're non-collinear? It means somebody's going to jump off the line, right? So we're going to have 3 non-collinear points. So I'm going to take a look, and I've got A, B, C, and D. So I got to have 3 points that are not on the same line. What do you think? Emma, what do you see? I'm going to pick on Emma. Do you see 3 points that are not on the same line?
Yeah.
Which ones?
A, B, and C.
Sure, A, B, and C, or A, B, and D, but certainly A, B, and C. Those 3 are not on the same line. A, B, and C, it takes two lines. So they're not collinear. They don't hang out all together on the same line. Line C is on this other line, and A, B are on the other line, okay? 3 collinear points. So 3 collinear means these, okay, I need points that are going to hang out together. They are going to cohabitate. So, Kurt, what do you think? 3.
B and C.
Yeah, there you go. Totally agree. D, B, and C. Totally right. All 3 of those are on the same line. Now, coplanar means they got to cohabitate. They got to hang out on the same plane. Okay, that means point E. Now, point E is a little tricky because when you look at point E, you think, well, maybe. You ready? Maybe if I stretch this thing out, maybe E's on it. But since I put it here, it could be above the plane, it could be below. We don't know. So E is the guy who's not on the plane. So 3 coplanar points. How about A, B, C or A, B, D? Any of these. How about A, B, D? Those all hang out on the same plane. And then E would be the non-coplanar. It's not on the plane. Okay? Thumbs up. You guys get the terms? Okay? So we're learning about points. When you describe points, use capital letters. Lines. Okay? 2 points make a line. Planes are that flat surface, right? Okay. Collinear and non-collinear. Okay? Turn the page. Now, mid-segments, all right? So, mid-segments, okay? To be a midpoint or mid-segment, it's in the middle, right? So, mid-segments means middle, okay? So, mid-segments, let's write some of this stuff down. Let's write mid-segment, right middle. So, if something's in the middle, it cuts it in half, right? 2 equal halves, right? And then we're also going to talk about a thing called a bisector, okay? And we'll talk about the bisector tomorrow. How about a midpoint? Midpoint, okay? So if something's a midpoint, it's going to go through the middle and cut it into 2 equal halves, all right? Harrison, where's Harrison Arnold? Harrison, there you go, I got a note for you. There you go. Okay. All right. So the length of AB. So you get this little formula, and I rarely use this formula, but I'll show you how the formula works. What's this little thing here? What's that little, what are these little dash lines here? Anybody know what those things are here? Anybody remember what those things are? Those little dash lines?
Like something to do with that being a separate
equation, but in the same equation?
Kind of, sort of, like maybe what you're saying is that it's absolute value.
Yeah.
And absolute value means it's kind of a separate equation. So that's like absolute value, okay? Come on, I can spell. Absolute value. There you go, I'll spell that better for you. Absolute value. Absolute, sorry about the spelling. Absolute value, okay. So absolute value means everything's got to be positive. I'll give you an easy example, okay? So if I were to get in my car, my truck, and drive from here to Cashmere, that's about 12 miles, right? Drive from here to Cashmere, 12 miles, right? Here to Cashmere, 12 miles. But I get back my truck and drive from Cashmere to here, it's negative 12 miles. It's negative 12 miles, right? That makes sense. I just drove negative 12 miles today. And Isaac's going, well, Mr. Davis, you drive backwards. No, that's illegal. I can't drive backwards. Distance is distance, right? So from here to Cashmere is 12 miles. From Cashmere to here is 12 miles. So length is always positive. So with absolute value, things are always going to be positive, okay? Well, I'm going to do this problem in a really easy way, and then we'll use the formula. But the way I would do it is I would find 0. I'd just say 0 is about there, okay? You guys agree? If I look at the number line, I've got A at negative 5.2 and B is 3.6. I put 0 about there. It doesn't have to be exact. I don't have to use a ruler, figure out exactly where it is. I just need a basic 0 to be somewhere where it belongs. It definitely belongs somewhere in there, okay? So then if I take a look, the distance from here to here, that's 3.6, yeah, because I go from 0 to there, it's 3.6. Now the distance from 0 to A is not negative 5.2. It's not. It is 5.2. And that's where the absolute value comes in, right? It has to be a positive value. So if I wanted the full distance, I just add them together, right? I go, okay, 5.2 plus 3.6, what's that, an 8.8, I think? So that'd be the length of that line. If I measured it with a ruler, put it down, it'd be 8.8, right? Can't be negative length, that's silly. So how does this little formula work? Well, that's easy. So if I use B, so I'm going to go, absolute value is going to be B, which is an absolute value of 3.6, minus A, which is minus a negative 5.2, okay? If I add those together, I get a 8.8 anyway. Absolute value of 8.8 is equal to an 8.8. So it's just using something, a formula. I really believe the easiest way to do is draw a picture. You're going to find in this class, I want you to draw a picture any chance you can. If you can see it, you can do it. Draw a picture. If you can see it, you can do it. Draw a picture. If you can see it, you can do it, right? Okay. Let's look at the next one. Congruence segments. So now here's this thing, word congruence. You guys are getting a lot today. That's good. Congruent, okay? Congruent is like equal, okay? Isaac, stand up, okay? Okay? Now, Isaac and I are pretty good friends, okay? But I wouldn't say I'm equal to him because he's far superior to me. So equal doesn't make sense, right? But we're pretty close to the same, so we'd say we're congruent. So we would never call two things equal. We call them congruent. Thank you. So what I'm going to do is this. Do these two line segments look like they're the same length? Do these two line segments look like they're the same length? How do I know they're the same length? They're both 10, right? They're both 10 and 10. So I would never say that two figures are equal. I'd say they're congruent. So we're going to say this. And you're going to same length. You're going to say CD. Okay, I want you to write this down. Write this down. And write this little equal sign with this squirrely top thing on it, okay? It's an equal sign with a little squirrely on top, okay? CD AB, okay? I want you to write that, okay? That symbol is the congruent symbol, all right? Figures can be congruent but not equal. Figures can be congruent. You wouldn't say two triangles are equal. You'd say they're congruent. You wouldn't say two squares are equal. You'd say they're congruent. Now, their measures can be equal because that's a number. So you can talk about CD being equal to AB only if we're talking about their length, all right? So we describe figures. We use the term congruence, all right? We'll use this a lot. Don't worry. If this is confusing, we will use this symbol all semester, right, Isaac? All semester, okay? All right. Example 3, finding a midpoint, okay? So you've got A to B. Am I doing okay? From A to B, the middle of this is somewhere. M is somewhere in there, okay? How can I figure out where that midpoint is? I want to find out where the middle is. I mean, it's got to be some number. I would think the length from M to B has to be equal from M to A, right? So if it's in the middle, it's got to be equal. So the length from here to here. So what is this total length here? What's the total length here? Anybody know what that is? 25? Okay, Keisha says 25. I agree because she went 18 plus 7, right? So to get the full length, I mean, zero's in here somewhere. Zero might not be there, but zero's in here somewhere. Zero might be right about here, right? So the length is 25. So the midpoint's got to be in the middle. What's half of this? What's half the 25?
5.
Okay, half of 25, 12 and a half, right? Half of that. Okay, that's half that. So if I want to find out what the midpoint is, I'm going to take my negative 7. I'm going to go up 12.5, right? I'm going to go from negative 7 and go up 12.5. All right, I can do that. So what is negative 7 plus 12.5? All right, isn't that a 5.5? Equals a 5.5. So that's actually the coordinate of the middle, of the midpoint. 5.5 is the middle. Okay, now how does this little symbol work, this little formula? We just did it. We just did it. We took negative 7, which is the value of A, plus half the length of AB, and we got it. Okay? That's another way to do it. Okay? All right, almost done. Example 4. If B is between A and C, B is between, is it in the middle? No. It might be, but I don't know. It's just between. So if I had, let me draw a picture. Always draw a picture, okay? There's A, and there's C and B. I'm going to put B somewhere in here, okay? AC is 14, so the whole thing's 14. BC is 11.4, so I'm going to put B right about here. Okay, I got B. Okay, there's B. All right, how am I doing? Mr. Daly, how are you?
Well, yourself?
I'm good. Okay, so let's go back to this. It's between. Is it in the middle? I don't know. It's somewhere, right? So I put B somewhere. Now remember, it's not in the middle. Might be. So the whole thing, AC is 14. Okay, all the way across 14. BC is 11.4, so BC is 11.4. Okay, so could I find AB? I'm hoping this is pretty obvious. Find AB. What do you think? Come on, you guys. How can I find this length? What do you think? Kurt, what are you going to do?
14 minus 11.
You guys agree? 14 minus 11.4? Nice job, Kurt. I agree. So to find it, we're just going to subtract. So again, have to emphasize, if you draw a picture, isn't it easy? If you draw a picture, it's so easy. So let's just go 14 minus 11.4. What is that value? What's 14 minus 11.4?
4. 3.4.
3.4, or is it 2.4? Because I got to borrow, I think. Got a calculator handy? Isaac, going to hand me my calculator? No, not your phone, please. Never your phone, right? 14 minus 11.4, 2.6. There we go. Glad I used a calculator, right? There you go. So, draw a picture, always. This is geometry. Example 5, we're almost done. S is between R and T, okay? S is between. So is S in the middle? Yes, no. How many say yes? Is that right in the middle? Is S in the middle?
No.
No. We don't know. It might be, but I don't think so. I know it's in between. So what do we know? Okay. It's not in the middle, so that I can't say that this is equal to that, but I do know that if I add this piece, right? Check it out. If I add RS with the ST, if I add this piece plus this piece, makes the entire segment, okay? If I take RS and add it to ST, it equals the whole thing, which is my RT, all right? Here's geometry, right? We're going to write from a figure the math that goes with it. So we got this piece, RS, plus ST equals the whole thing. Well, okay, now let's just put in the values. Let's substitute. RS is equal to 2x plus 7. ST is 28. And it equals RT, which is 4x. Okay, write that down. I want you to think about what I just did. Okay? I got this piece. RS plus this piece makes the whole thing. Okay, that makes sense. Now, can we solve for x? Hopefully you can. Okay, what are we going to do? Katie, go ahead.
We're to add 7 and 28.
I like that. 27. What's 27 plus 28? I got it. 28 plus 7, hopefully. 35. Okay, now what? Doing great, Katie. Keep going.
Then divide 2 by 4.
Not yet. Let's go subtract 2x. How about minus 2x, minus 2x, right? We got x's on both sides. So then we get a 2x. We got a 35 equals 2x. How am I doing?
Or then divide 2 by 2.
There you go. Let's divide by 2, divide by 2. X is equal to, what's 35 divided by 2? Probably 17.5, but you know, probably 17.5. Okay, is that the answer? No,
No,
thanks,
that's
Kurt.
x.
Yeah, that's not the answer. What's the question? What's the question? So 17.5 is not the answer. What's the question? Find RT. So RT is 4x, right? So let's put the 4x in there. So I'm going to go 4 times my 17.5. 4 times 17.5. And I get an answer of 70. Okay, that's the answer. Last one. Midpoint. Now that is a different word. What does midpoint mean to you? What does midpoint mean to you? Kurt, what does midpoint mean? It's in the middle. So if it's exactly in the middle, what do you know about these two sides? They're equals. That makes sense. If it's midpoint, then it cuts it right in the middle, cuts it in 2 equal parts, so this side's equal to this side. So let's do that. Let's put these two things equal. Let's make sure we say, okay, I know that AB is equal to BC. All right, that's what we're saying. AB is equal to BC. Because we cut it, B's a midpoint, cuts it right in the middle. So then I can say, well, 5x is equal to 3x plus 4, right? Solve for x. Mason, what would you do to solve for x?
Minus 3.
There you go. Minus 3x. Everybody agree with them? I agree. Minus 3x, minus 3x. 2x equals 4, then what?
Divided by 2.
X equals 2. We're done, right? That's the answer, right? We're done. Time to go home. Mr. Daly shake his head. He goes, no, we're not done. Why would Mr. Daly say we're not done?
We have to find AC.
Yeah, what's the question? Nice job, Kurt. We're going to find AC, not X. So AC, well, I don't know all of AC, but I do know if I put 2 right in here, 2 in for X, 5 times 2 is 10, right? I could put 2 in here, but I wouldn't have to because I know these two sides are equal, aren't they? I know these two sides are equal. So if that's 10, that's 10. What's the value of AC?
20.
20. Very good. All right. Now, I'll go ahead and stop this recording.